The cumulative distribution function or the cumulative mass function is that we are going to see in this lesson, but please don't forget to subscribe the channel. Now, the cumulative, like you know how we are getting the cumulative frequency in statistics, this is similar to this in this spread. We just keep on summing the probability from the first probability up to the last probability, and always the last probability should be the last cumulative frequency, and the last cumulative mass function should be a 1. So this is sometimes called a CDF, and for a random variable x with the PDF this, then its CDF is given by capital F, given by this, so that this one means it's cumulative, given that we sum from x equaling to 1 up to the first, meaning the first x, small x, up to the last x of these variables. Let us see how we handle that. So a random variable has a probability distribution table below. This is the table below. Find probability of this. So we first handle this. This one is, you see there, I want us to handle the probability of x greater or equal to 1 given x less or equal to 3. And so that this one is the ideal of given probabilities are the conditional probabilities. And said if you have A given B, you get the intersection of the two over the probability of the last. So here we have now probability of x greater or equal to 1 given probability of x less or equal to 3. So here what we do in simple terms, you can draw a simple let me say a simple number line. You have 1, 2, 3. So probabilities which are above or equal to 1, we have this. So we have this up to this side here. But this one which are less than 3 means that we are going to start from here up to here. Up to here. Less than 1, we remember we have 0. So we are going to less than 3, we are going to start from here up to here. So now the intersection of these two, so where are they intersecting? So they are intersecting in this region here. So this is the intersection. Then when this is less than this, you get this, this, and this. But when this one is greater or equal to 1, we have 1, 2, and 3. Because this one was just less, means that we start from 2, 1, and 0. So the intersection, what we are interested in, you see that it's going to be the probability from 1, 2, and 2. Because you see that where they are making these two. So this is their intersection, so they are intersecting here. So now this will be probability of this x greater or equal to 1 intersecting x 3 over probability of x less than 3. Now we have seen that where the intersecting is probability from 1 less or equal to up to 2. That's where the intersecting over the probability of x less than 3. And this will be probability of from 1, probability of 1 is here, and 3 over 8 plus probability of 2, which is also 3 over 8. They're all over less than 3, we start from 2. So probability of 2 is 3 over 8. Probability of 1 is 3 over 8. Then probability of 0, which is 1 over 8. When we sum up, we have 6 over 8. When we sum down, we have 7 over 8. And so now, this probability here is going to be 6 over 7. Now, when 2, and in part B, I want us to get the cumulative distribution function. So, we say our f of x is given by probability of x less or equal to. Now, our first here is that is when x is equal to 0. So in simple terms, we keep on adding and adding. So when x is equal to 0, now we have f of 0 equaling to probability of x less or equal to 0. But for me, less or equal to 0 is the same thing because we don't have anything else, which is going to be 1 over 8. Then when x is 0, the next value of x is 1. So we having f of 1, which will be probability of x less or equal to now is 1. And we have seen that this is the same as when you have probability of x less or equal to 1, it means that we are going to use the probability when x is 1 plus probability when x is 0. That's why we shall add when is 1 is 3 over 8, and when is 0 is 1 over 8, and this will give us 4 over 8. So when x is 2, when x is 2, now we need the capital F of 2, which will be now probability of x, now less or equal to 2. Means that we shall sum the probabilities when x is equal to 2, when x is equal to 1, and when x equal to 0. We have seen that these two here, their probabilities was 4 over 8 plus 2 is 3 over 8, which will give us 7 over 8. Then when we come to when x is 3, we shall now have f of 3, which will be equal to probability of x less or equal to 3. So we shall sum, now we shall sum from 3. We'll get probability of x equaling 3 plus probability of x equaling 2 plus probability when x is 1 plus probability when x is 0. So this is 1 over 8 plus 7 over 8, which will be 1. So the PDF now of this, we have seen that we have finished. So the highest is when we have 1. So if they ask you to construct that table in simple terms, you construct this, then you give their corresponding here, give this, you also give this, and also you give the 1. For the last, always the last should be giving you 1. In simple terms, you can keep on adding this plus this, then this plus this, then this plus this. That's how you can easily handle that. Now, after doing that, how can they apply this idea? They will give you a discrete random variable x has a symmetric distribution function, this given by this. So then they're asking you to find the probability distribution function. So let us see what happens in our solution here. Now, it means that now my f of x, first of all, is equal to x over k. Meaning that now, when x is 1, I'm going to have f of 1, which will be 1 over k in the place when I put here. Okay. So when x is 2, now my f of 2, this is now capital, will be 2 over k. When x is 3, I have my f of 3, which will be 3 over k. And then when my x is 4, I'll have my f of 4 equaling to 4 over k. But we're saying, how do we get the value of k? Because to get the value of k, I need to get this distribution, we don't need this value of k. Now, how do we get the value of k? But recall, but note that, always, the last value of this function here should be always 1. f of 4 should always be a 1. Why? Because it's that here our last value was 3. And this probability function, the geometric probability function, was 1. Means that now, if this was also the last, means that the whole of this should be 1. So meaning that now, my 4 over k is 1, implying that my k is a 4. So after getting the value of k, it means that now from here, my f of 1 is going to be 1 over 4. My f of 2 will be 2 over 4. Then my f of 3 will be 3 over 4. Then my f of 4 will be 4 over 4, which you can see it's obvious 1. Now to get a CDF, the simple terms what we do is that always, so when x, now we need to get a CDF for this corresponding thing. When x is 1, it means that always the first CDF is equal to the probability of that first figure. So it means that now here, my probability of x will be equal to 1 over its corresponding probability, which is 4 in capital F of x. I'm repeating this. It's start now. When we wanted to get the first cumulative mass distribution for this, our f of the first value is giving us the exact probability of that. So always the first cumulative mass function is the same as the probability of the first value of x. That's why for the first value of x, if it's it means that it's going to be the same probability of the probability function. The probability function, this is the probability function, this is the probability mass, cumulative mass function. That's the difference. Now, when x is 2, my probability of x, this is when x is 1. When x is 1. When x is 1. So when x is 2, it means that now look, if we had substituted this 1, we added it to the first, then plus this. Means that now, if we shall get this minus this to get the other one, we shall get now f of 2 minus f of 1, which will be, you always get the one above, the one corresponding to this, minus the one which is first. Why? Because f of 2, okay, the next is always combining the first and the second. F of the second here is 1. So the second is combining the first and the second, the first and the second. So to get now this, you get this minus this, will be getting this. So that's why I'm getting f of 2 minus the first. My f of 2 was 2 over 4 minus f of 1, which is a quarter, and this will give me 1 over 4. Now when x is equal to 3, our probability function when x is 3 is going to be f, now f of 3, you get this minus the one lower. So you get f of 3 minus f of 2, which will be 3 over 4 minus f of 2. Our f of 2 is 2 over 4, which will be a quarter. Then when x is 4, the last, I'll get my probability when x is equal to 4, which will be now f of 4 minus the one below it, f of 3. And you see that this will give us 1 minus, because this is 1, minus the one below it, which is 3 over 4, 3 over 4, which will be a quarter. So meaning that now, the corresponding probabilities, you have them, and you can easily draw a table for them, like this. You can include here your x, then you include here probabilities. So when x is 1, we have seen it's a quarter. When x is 2, it's also a quarter. When x is 3, it's a quarter. And then when x is 4, it is a quarter. Because this is now a probability distribution function. I think now members, you can easily get mean. You get mean in some this times this plus, this times this plus, this times this. So our expectation there, you see that when you add, you get 1 times this, you get a quarter. Then plus 2 times this, you get 2 over 4. Then plus 3 over 4. Then plus this times this, 4 over 4, which will give you, this will be 10 over 4. And this is 10 over 4. When you add, you get this times this, this times this, this times this times x times its probability. Then you sum them. So that's how we handle the cumulative mass function of this. We are going to see how you sketch it and how do you find the median if you are given the cumulative mass function. See you.